All right, good evening, everyone. We'll get started here. Welcome to another exciting night of .NET Learnings. So, I'm your host for the evening, Alan Barber. Let's get started with some slide decks, and then we can get right into the talk. All right, y'all know we got our meetup. Please sign up, follow it, so you can be notified of events. We do actually have a website, but that just redirects you to Meetup, and there's Twitter, and I think our Facebook still works. I don't know. I haven't checked it in a while, so actually we should probably just take that off because we don't really post on Facebook. We have our YouTube live streaming right now, in fact. We got just over 100 subscribers. I think we might be at like 104, 105, so if you haven't subscribed. 106, we have an update. Woo! That's awesome. All right. For everyone here in the office, just please remember we are live streaming, so help serve our bandwidth. I'd like to throw out thanks to our sponsor Improving, giving us the location and the pizza in the back there. And so thanks, Improving. You're welcome. It's awkward. It's awkward when I work there. All right. We'll also be giving away some raffles at the end of the night. We have some JetBrains licenses to hand away. And we like to give a shout out to some of the other user groups in town. There is a Central Ohio Azure user group. They meet the second Monday of every month. I'm not sure if they're in person or they're still doing virtual. I haven't heard anything. So I'm not sure. Check out their Twitter or their meetup, and I'm sure they'll have something. I'm pretty sure they posted something that they had some event coming, but I didn't pay attention if it was live or whatever. There's also the Columbus App Dev user group. They meet every third Monday of the month. Same deal. I'm not sure if they're live and in person or still doing.
They are virtual.
They are virtual right now. All right, so there you go. You can check them out on meetup.com/Columbus App Dev UG. There's also the CBus Data. It used to be CBus Pass, so that's your Microsoft Data Platform user group. They meet every second Thursday of the month. You can hit them up on Meetup. And again, I'm not sure if they're live or virtual or what, so figure it out. All right, I'd like to give a little shout out. This is technically an Improving event. Code launch, it's basically, we're running this Seed Accelerator competition, technology trade show, startup conference. Signups are open right now, so if you had an idea for a new tech startup, mobile app, biz, whatever, you can actually register, and part of that will give you some dev time, we'll give you some guidance on actually starting up the company, and then we run a little competition on August, actually, I believe it's August 24th, I forgot the venue. We've announced it, but I forget where it's at. And then we'll have like a little competition, and we'll have some panel judges that they'll do a pitch deck to. They'll vote for the best one, and then they'll get a little bit of funding for it. And so you can go to codelaunch.com to find out more information. Actually, I forgot to remove April's. But this month, we got Introduction to CQRS Pattern with Mediator. That's me. Next month, we're going to have Test-Driven Development with Ron Kincaid. July is our lightning talks, which I'll talk about in just a minute. In August, we'll have Rosalind Analyzers with Chandler. And then September and October still open, so if you want to give a presentation, or if you know anyone that has a great presentation you think would be wonderful to share, let us know, and we'll either get you put on the list, or we'll try to contact that particular person and get them lined up. And of course then, end of the year, which still seems pretty far off, but will come by so fast, will be December and our holiday party. All right, lightning talks. So these are short presentations on any topic of your choice. We just say it has to be at least something useful for a .NET developer. So it can be JavaScript frameworks. It can be, a tool. Maybe you want to show off how you like JetBrains Writer and how it helps you be so much more useful than Visual Studio. That'd be an awesome talk actually to show off some of those comparisons like that. But either way, 15, 20 minutes we like to say. Keep it a couple of minimal slides and one quick demo, and this is always my deal, no live coding please, just so that you don't get stuck in the weeds and end up spending 15 minutes just trying to get your code running. So we'll have 6 slots available, first come, first serve. Don't think we have anyone signed up right now, so you basically have 2 months, give or take, to sign up. Otherwise, it's going to be me up here again, giving talks.
I'll come too.
There we go. We got at least one more. So for anyone here or virtual, feel free to throw up. If you're looking to hire, raise your hands or virtual hand and say you're looking to help hire people. And so if you're looking for work, talk to one of those people. They'll help you get connected and maybe you can get yourself a better job. You know, one of those ones that actually let you work, work from home full time maybe. And finally, as always, we like to pitch that you can be part of our team. We are not, gods and awesome people. We are just everyday Joe Schmoes trying to keep this thing running. So we're always looking for people to help us handle things. And it doesn't take much work, a couple hours a month at most. And you can, brag about it, put it on your resume, put it in your LinkedIn. Again, maybe it'll help you find a better job. So if you want to, come chat with us afterwards and we'll see what we can do. So with that, let's get switched to Bink. All right. Hello, I'm your presenter for the evening. My name is Alan Barber, and we will be talking about CQRS and Mediator. And so this is basically your introduction to CQRS with Mediator. So who am I? I am, Alan Paul Barber. I'm principal consultant here at Improving, .NET Foundation member, software developer, computer scientist, scrum master, as we were talking a little bit before, small-time crypto investor, Crohn's disease fighter, got dark, and husband and father. And there's me with my kid a couple years ago when the Muppets came to COSI here in town. We got to see them up, and those two are my favorite Muppets, so I was so excited to get to see them in person. So, although now the kid's 4 years old, so it's been a while. Disclaimer, as always, I'm no expert. I'm still learning. I make no guarantees about anything. Quite honestly, I have no idea what I'm doing. I'm just figuring it out as I go along. And so this is just a topic that I'm kind of excited about and I've done some work on, so I wanted to share it with you. So, what are we here to talk about? Well, we're here to talk about CQRS Pattern, which is just an architectural pattern that helps organize our code. There's the Mediator Pattern, will be talked about as well. That's just a behavioral pattern that defines how objects interact. We'll go into details about the MediatR Library itself to show that off, and that's just a simple implementation of the Mediator Pattern in .NET. And I felt like sprinkling on a little bit of domain-driven design, which is just a design methodology that focuses on building software that matches business domains. So let's start out with domain-driven design so I can put you all to sleep. What is domain-driven design? Well, we can go look at the all-knowing Wikipedia and see what it has to say, which is just that domain-driven design is a software design approach focused on modeling software to match a domain according to the input from the domain's experts. In terms of object-oriented programming, it means that the structure and language of software code, i.e. your class names, your methods, your class variables, how you structure the entire projects, they should match the business domain. So for example, if you're doing software that processes loan applications, you should have classes that are named things like loan application and customer, not user and loan object, because that's not how the business talks about it. They talk about it in terms of customers. And similarly, you should have methods that have things like accept offer, withdraw, or add new customer, not add new user. Things like that. It's all about focusing on using a common shared language between the business and software developers. So when they talk about things, you don't have that mismatch of what's happening in discussions. Quite honestly, that's all I want to talk about domain-driven design. It's a huge topic. There's a couple of books which I'll share at the end to read that they're all about 1,000 pages each and take you months to read and really understand. And it's not something that you can quickly learn, but I find it quite useful and I encourage everyone to start learning about domain-driven design. All right, so we'll dive right in here to the CQRS pattern. What does it stand for? Well, it's Command Query Responsibility Segregation. It's a bunch of big words for a pretty small idea. So what is CQRS? Again, let's go ask the all-knowing Wikipedias. It's a principle of imperative computer programming. It states that every method should either be a command that performs an action or a query that returns data to the caller, but not both. In other words, asking a question should not change the answer. And if that doesn't confuse you to all ends, try to think about it this way, is that fundamentally, you're trying to do one of two things: either change data in a system or read data in a system. And how they operate and how they should be set up should be separated because they fundamentally operate in different ways. So just think about that in the back of your brain as we kind of go to it. So, let's be honest, what does every app truly do? Everyone knows CRUD, create, read, update, delete. Doesn't matter what application you're building. Doesn't matter if it's a mobile app, a desktop app, a web app. Doesn't matter if you're in banking, insurance, fast food. At the end of the day, all applications are creating data, they're reading data, they're updating data, and they're deleting data. Nothing more, nothing less. They just do it in fancy ways. So, I'd say one of these is not like the other. This is where CQRS kind of comes in and says, let's break it down. We have, again, our commands. Those are the things that are changing the data. We have our queries. Those are things that are just looking at data. So we have create, update, delete as commands. Queries are read. Hopefully that makes logical sense to everyone. And sort of the idea here is you want to focus on actions, not objects. So one of the things that we'll get into in more details is the idea of no more building of monolithic objects and services. When you start thinking about the standard designs of software, you have your billing service, you've got your user service, you've got your order service, you've got your whatever service, the payroll service, the payment service, the reporting service. Everything becomes these large jumbo objects that have all this functionality for manipulating data. We want to change that thought and say, let's focus on creating small modular code blocks that are only focused on processing the commands and the queries. So, benefits of splitting it up. Well, it's simplicity. Instead of having those giant, as sometimes they're called, the God object or the God service that ends up being, I'm no kidding, I've seen 20, 30,000 lines of code in a single object, which is insanity. You don't know, and then they're calling functions that call functions that call functions that go back and call functions recursively. Your brain melts when you try to understand it. So this is about focusing on individual small pieces and keeping the code simple so that it's easy to understand. Reliability, again, those big, giant, monolithic God objects, they're horrible to maintain. You end up getting so many bugs, there ends up being so much code that's written that's just defensive to make sure that the data came back this right way because this function gets called by 3 other functions that all expect the data to be slightly differently, so you end up writing all this code to check that it's correct. Start breaking things into smaller pieces, it becomes easier, it becomes more reliable, less likely to cause errors and bugs. Security is another one. Simpler code, again, makes it easier to look for things and go, someone could potentially use that as a SQL injection point. We should probably not do that, because you see those things more easily. And it also makes security easier because most times you want to lock down creations, updates, deletes to certain users or certain groups of users versus reading data. So simplifying the code makes it easier to put in security around them, things like that. And the biggest one when it comes to CQRS, which is the biggest selling point, is scalability and performance. Now, you could go into a whole lot of details on this one, but I'm just going to kind of take a higher level hit on it. But as you need to start scaling your systems, quite honestly, sometimes you'll end up doing things like maybe setting up multiple databases. So you'll have a master, read-write database, but then there will be read-only copies. When you build it with the CQRS pattern, it makes it very easy to focus all those commands to target that database that you can write to versus being able to scale out and potentially hit 2, 3, 4, 10 read-only instances that keep synced from there. Or even you could not go straight to a traditional database. You could use a document database for the reads, because every time something's updated, then it updates the document database with data structures in a completely different format than the actual main database. That's one of the things that a lot of times they talk about as one of the benefits, is that you can form, so every time you do a write or a delete or an update, a back-end part of that will be update some different version of the data that's already in a perfect format. So you don't have to worry about doing joins that are slow, because the data is already basically pre-processed and organized in a way so when the queries come in to say, give me a list of users, the user list is already formatted perfectly for pulling that data out, which can make it a lot faster and improve performance. So there's some benefits to that kind of thing, that when you start splitting them up, it gives you that power of being able to say, I want to do things completely differently, which is quite often hard when it's just one big master, order service, trying to have it linked to many different versions of how to store and process data. So this is sort of your traditional N-tier, 3-tier, whatever you want to call it, application that most people build and we all work with pretty much on a day-to-day basis. You got your UI front end, that could be your mobile app, that can be a web interface, it could be whatever. You're going to have some kind of API, usually it's an API layer, so you have your web app, it's got a controller, and then this is the traditional with the services. You got your order service, you got your user service, you got your whatever service, and then there's some data access. Usually there's a little bit of data access either directly on the services or perhaps even an abstract data access layer, and you hit your database. Here's what CQRS plus Mediator is proposing. Still basically the same layout, except now the controllers are going to be talking in terms of your commands and queries, and it's going to be a bunch of small, what they call handlers, code blocks that are independent to process those requests. So if you have a query for get all paid employees, there's going to be a get paid employee query. That message gets sent, which we'll cover how that kind of all works in a minute here, but there will be a handler that will be there to respond to that request to get all paid employees and do that. And so that's where all the code gets. Boop. So now we need to tap into the mediator pattern. And this is where things will start to hopefully make a little more sense as you kind of build it. And this is where I kind of want to mention domain-driven design, because this is one of those focuses that kind of, when you start talking about domain-driven design, you start talking about things like, well, CQRS is great for that because when you think about those ideas of commands and queries, those are business actions like, pay employee or bill customer. Those are your commands. Well, that works hand in hand. So now you just need something to kind of connect it all together. That's where the mediator pattern comes in. So, trying to be funny here, but I think it's time we break up. Nope. Sorry, I meant the code. I still love you. So, what is the mediator pattern? Well, again, I like asking the all-knowing Wikipedia. Please tell me, yo master of knowledge. Well, it's with the mediator pattern, communication between objects is encapsulated within a mediator object. Objects no longer communicate directly with each other, but instead communicate through the mediator. This reduces the dependencies between communicating objects, thereby reducing coupling. And again, it's kind of an academic definition and probably doesn't explain it totally great, but it's a good start. So this is sort of the normal way we think about it. These could be any of those, the big God object has the end all be all, but it still needs to go to the payroll service object, and it's got to go to the user service, and it's got to go to the whatever service, and then, and no joke, I have seen ones that have connected back and forth. You go in object A, and you need to call something in D that goes to C, that for whatever reason needed to go back to A to call to get something, and then the chain all rolls back around. Psychotic. Again, your brain goes, why? But it's because as we're developing these systems, there's just, we end up trying to create these little boxes that code should go in. So you're like, well, where should that go? Well, that's a customer related thing. So it's got to go in the customer service, even though it probably could have been kept in, the report service and just a function that said, process customer, whatever. We've dictated anything related to dealing with customers has to go in the customer service. And this is what ends up happening. So the mediator way says, well, we're going to do loose coupling. We're going to create this central authority that anytime you want to talk to anything else, you got to go through it. So it's going to be the end-all be-all knowledge of how to communicate with all these. And so you just go, hey, mediator, I need to do something related to customers. So again, this is where now we're connecting back to that CQRS idea. There are these commands or these queries. So you're going to be going to the mediator and saying, get customers that have been billed or whatever. The mediator will know that there's going to be something there to process that, which means it needs to go to object D to run that functionality, something like that. And that's where you kind of go with it. So now that we've got that, we can talk about the mediator, slightly spelled differently as you can tell. Library. So hey, what do you know? There's a library for everything. So mediator is just a simple mediator implementation in .NET. It's an in-process message. It does in-process messaging with no dependencies. When you start looking at this idea of mediator, a lot of people start thinking of ideas like event sourcing or service buses. Kind of it. Your brain immediately kind of goes, that feels kind of like a service bus or an event sourcing system. This sort of is, but this is in process. Okay, so you're not having to spin up any big service with TCP/IP layers that are communicating. This is just a in-code, simple implementation to getting everyone talking together. So it supports the idea of request responses, commands and queries, notifications, and events. And it does sync and async, and it all works with C# generics. The latest version, which I realize that they didn't add that in there, they fully support things like the use of streams now as return types, so you can do stream-based things. And it works well with, and really you do really kind of need a DI framework to use it effectively. So they've already added support with helpers so that you can connect into the Microsoft's FAC, Inject, Castle Windsor, and basically every other one possible. You can roll your own to kind of connect all the pieces together, but it's better if you allow it to just use the standard Microsoft DI framework if that's what you're using. So fundamentally, what do we got? Again, your brain kind of goes back to CQRS. We start mentioning commands and queries and responses, and it's messages and handlers. That's all that's really kind of happening here. And to be clear, I'm only going to focus on a subset of Mediator because, again, it does a lot of things. I'm really focused on just their basic request response functionality, that means it's a one-to-one. You make a request, one handler is going to run and return data. You can't have multiple handlers run because it's kind of confusing on, well, if two things return data, which piece of data do you look at? And the plumbing gets a little crazy. There are ways to do that. People have done some of that to like do weird things. Try not to. It's a little confusing. The other major question? Yep, of course.
I'm sorry, did you say that there can only be one subscriber for each? I don't know, is it you or channel or?
Yeah, like I said, because this is in process, this isn't like a service bus where there's going to be a whole bunch of subscribers listening for messages. It's in process, it's in one running application. So its focus is on one message gets sent, there's one handler to process the message. Now, if you want multiple things to run that don't return, there is a thing called notifications, which are basically fire and forgets because you're never going to get a data return. That will allow you to actually wire up multiple handlers so that you can send them. It's still basically the same idea, a message, but instead of it being a request and a response style, it's a notification that basically you throw in ether and you hope something ran and did something, but you'll never get any response back that anything actually did run. You know, it's async, it fires off and it runs. So then you could have 10 little mini handlers do everything. But again, it's in process, there's no built-in threading, there's no, you know, optimization for any of that kind of stuff. So this is sort of a bare bones implementation for that kind of thing.
But obviously, even though there is one handler, that handler can be informing many different query schema objects, right? There are lots of consumers to the same command, same single event. So that obviously is up to you, right? Just by plain feature of being a C# method, and you can fire 12 events in the handler, updating many different queries, right?
Well, yeah, you can do as many messages and handlers as you want, but it's always going to be a one-to-one match. So you'll have a specific message that's a request of some kind, and there will be a handler that responds to that message. And it's always one-to-one. So looking at some simple code, I should have centered that. That's kind of silly. I put that up there. Sorry.
So is it by polling or subscription?
I would call it polling. Well, not even polling. Like I say, this is direct linking. This is where the mediator is kind of hiding things from you. Like I said, this is in process. This isn't multi-threaded. There's no background service that's listening. This is you send a message to the mediator saying, "Hey, I want," which I'll show you in just a second.
Okay.
I want you to respond to this message. It's going to figure out the handler that would respond to said message, run that handler, and give you the results back. It's not sitting there. It's not like background thread waiting for messages, and you can't queue up multiple messages. This is a very individual one-on-one fire. This is just a way of wiring together objects. It's not designed as some kind of advanced event-based system or message bus. So where was I? Okay. This is like the bare bones minimum example. We got a ping message, which basically says it's an I request, which is the mediator's idea, and you tell it the response type. So if anyone makes a message saying, I want to make the ping request, or I want to send a message saying ping, I'm expecting that I'm going to get a result back that is a string in this case. And you can do anything in there you want. Obviously, this is all the fun of generics. So you can do lists of objects. You can do an object that has nested objects 50 levels deep. Doesn't matter. It's just you're just saying, someone says, fire off the ping request. I'm expecting a string to get back. Here's our bare bones of a handler. We have our ping handler, which says it's an I request handler of ping. So it's gonna handle the ping message, and you have to specify again the return type, which I hate that that's something you have to do. It's kind of annoying when you're writing a lot of these things over and over again, but that's just a limitation of C-sharp's generics. You can't look inside another object's generics for the return types. I don't know. It's one of those things you have to specify it twice that you're expecting a string to be returned.
What do you do if you want just to find forget the return?
I'll have an example for that later to kind of show that. But that would be like one maybe where you would use the idea of the notification, which is a I notification. Yep.
Namespace is all the same.
I believe it's all under just mediator.
Okay.
Can you repeat the questions?
Oh.
We've got
Oh, sorry. Yeah.
the guys online.
I know that's right.
No worries.
Sorry, people. I'm terrible. Bad Alan. Yep.
They can guess the question.
Yeah. All right. All right. I'll try to do that in the future.
All right. Do what?
Okay. I will try to respond to the questions. Repeat the questions in the future. Okay. I got you. Thank you. I'll figure this out. Don't worry.
We got it. We're in this together.
So here's your I request handler. Like say it's gonna be handling the ping request type, returning a string, which is just a public task handler. The request comes in, which is the ping object. It passes in a cancellation token because these can all be async if you want them to be. Technically, I mean they are, but they're doing tasks. And in this case, because we're not doing anything, we're just returning a string pong. So every time you send ping, so here's sort of a sample of what it would, once you new up an instance of the mediator and it's all properly configured, which is really easy to do, you just say response equals wait mediator.send, new ping, and you get your result. And then I think that might kind of help explain what you were kind of asking. That, and same deal. It's straight. I'm expecting a response. Mediator, get me the response. It's handling, wiring up things, calling the handler, and running whatever codes in the handler, which probably is, in a more complex example, is going to be, referencing other objects. It's going to reference your data access layer. It's going to reference your billing service if you have a complex billing service that you need to. Because there's nothing that says you don't have to use service. I know it's kind of like ranting on, like, don't build big services. You still obviously can have services, but the idea is to focus on those of being functionality, small packages of functionality that actually make sense to package together. So like a billing service, it's just going to make API calls to, Chase Bank or whatever. And that's all it's doing behind the scenes, but it's not going to do any heavy lifting. That would all be done in your handler is the idea. So, any questions? Okay. All right, so now we're at the fun of demo time. We are going to pray to the demo gods that everything works well. And for this, I am literally going to live demo, so everything I say not to do to people in lightning talks, I'm going to do. I am that crazy. Yes, I am. We're going to go ahead and call this one for lays of purpose web application 1, because I don't care. If you haven't seen the new stuff with .NET 6, there's a whole lot of configuration now of if you use the minimal API controllers, if you support Open API, if you want to use top-level statements, all that fun stuff. I'm an old fart. I don't like the new style. It's icky, and it makes me not like it. It's basically a standard for defining API endpoints and how they communicate so that you can more easily connect things to them. And I didn't respond to the question. And I just realized that after it. He asked, what is Open API? And I failed to repeat that. I'll get better, I swear. Okay, just keep yelling at me.
The answers are incredible.
Yes, I'm sure they are. All right.
Oh.
Yes?
Sorry. Well, since we had to ask about OpenAPI, I can ask about the next one. What are top-level statements?
Okay, so what are top-level statements? I'm not an expert on .NET 6 and how it all works, but the concept is that you don't have to do the standard namespace bracket in there. You don't have to put usings at the top. There's like a shared global usings, and you can literally just say namespace whatever without the brackets, so everything will shift over a space. They're trying to clean up and simplify some of it, get rid of a lot of the ceremony of how you normally would format code, which, like I say, I'm not a fan of, so I like my namespaces with brackets like this. So hold on here. I should probably zoom this in. Come on. All right. So the first thing we're going to do is, well, I'll run this application just so that everyone can see what it does. This is your base demo for new web APIs that they've set up, which has this wonderful weather. It's a weather forecast service, basically. This is part of the Open API. It's a thing called Swagger.
So Swagger is an open API.
It's part of the Open. Swagger is a graphical implementation of the Open API, is what, yeah. So this is.
So when you check it, it renders Swagger for you. That's
Yeah, when you check that, it'll add Swagger to the project so that you can do this. And I'm doing this just because I don't care about the front ends. I don't want to deal with writing a bunch of React app or Angular app or, God forbid, some classic, web forms, ASP.NET stuff. And, yeah, no one has time to deal with that garbage. I'm just focused on CQRS and Mediator. So we're focused on the middle of the tiers here. So here's your basic. This is all they're feeding you. Try it out. Ugh, so many buttons you press. And it gives you, whoa, scroll too hard. Some weather information. All right. So let's kill that puppy. I know. I'm horrible. All right. So the first thing I want to do is build out part of, this is where I wanted to sprinkle in a little domain-driven design. This is sort of your bare minimum. You just happen to read part of the domain-driven design books, and this is what you end up doing. So this is like not exactly the best way to do it, but we're just going to go ahead and do it this way because why not? Where's my, used to a larger screen that I can actually look at. Oh, shoot, there it is. Wrong one. Add, new project. We want to do a class library. So now there's going to be a data access project. Class library. We're going to call it domain because there's no better, I mean, I guess I could call it the weather app or something like that, but this is where your domain logic goes. So all the business logic would be in your domain project. Then, finally, well, this one is sometimes debated if it's actually needed or not. Some people say it should be for effective code reuse. Others don't like the idea. A models project where you define all your models. It's hotly debated, and I've been in plenty of
That's exactly what I use.
many discussions. People have gone both ways of yes, no, no, yes. You know, let's just, I'm in charge, I get to do it. All right. Yep. Sorry. Not used to using my touchpad here. All right, so the first thing we're going to do is do a little code rearranging. Right now, there is this weather forecast object that needs to go into our models. And we need to change our namespace. We're going to make that go bye-bye. I don't know why it does that when you drag and drop, why it decides to copy instead of dragging and dropping, but
It's in a folder. I think it changes.
all right. All right. I also want to add a tiny change here because any real data access is going to have an ID. We all know it. You can't live without IDs in any real model. Now I'm going to cheat for just a minute because I'm not going to bore you with a whole lot of code. And I'm going to grab because I'm not actually going to set up a real database or any of that kind of stuff or any actual real data access. We're just going to have some dummy data access. Whatever. Oh, come on now. All right. Now a couple of things we got to do here. Yeah, I got to do some project references. Where's my? All right, I got dependencies. There we go. So the data access layer is going to need to know about models since everything's in there. Our domain. I keep doing that. Ah, come on, one down. It's going to need to know about models and data access. And our web application really just needs to know about the domain. It'll carry everything forward and up. Let's catch all our, there we go. And we'll just leave it named that way. I should probably rename that object, but either way, that's fine. So now, we have a controller We're going to rip out a whole lot of this. Because we don't need any of this stuff anymore. There, for now, just so it doesn't whine. All right, at this point, we now have our basic project set up. We have our web application, we got our data access layer, our domain, which has nothing in it at this point, but we'll be adding stuff there shortly. And we have our models, which at this point is just a weather forecast object, and our web application. Now we need to add something new. Manage NuGet packages. All right, so for this one, because I know I'm going to be using the standard Microsoft dependency injection, I'm going to make a reference to the Mediator extensions Microsoft dependency injection. And this needs to be added both to the domain project, because we'll be making references to Mediator, and the web application itself. You can see the latest stable versions up to version 10.1. So we just install, and that's the only two that need it, is your domain and your web application. So hit OK. Wait for it to finish. Hey, what do you know? All right. So down here in our program, this is the startup program the web application runs. We're going to do two things. We're going to add here builder.services.add. Oh, come on. Why is it not working? Come on, be nice. Add. There we go. See, it's smart and it understands these things for you. So this is the DI framework. It taps into the DI framework, and what you're going to do, and actually I need to change that to domain. Actually, all right, I got to do something real quick, but we'll change that in just a second. This is, you're going to tell it basically your assembly where all of your requests or your Mediator messages, so all those I requests are, and where the handlers are. And it's going to, this little function here will get them all figured out so that you don't have to actually wire up anything by hand and say, this message gets called this. It's doing all the heavy lifting of doing a bunch of, behind the scenes scanning your assembly and finding all those I requests and all those I request handlers and doing the heavy lifting of wiring those things together so that they'll all magic. It's all magic. Just don't worry about it. It's magic. And then the other thing, add. It should be add singleton. Well, I don't want Mediator. Is going to be our data access dot. Oop, helps if I spell it right, wouldn't it? Hey, there we go. That's better. Again, this is just because I don't have an actual database, data access layer. I'm just doing a singleton, and we're just going to do a little hand waving on that one, but I can show you a little bit just because I'm sure everyone will want to know. Basically, instead of having an actual table, we're just going to have a private read-only list for our weather forecast. When it news it up, it preloads a couple of random weather items, and then I got some helper functions for get weather forecast, insert weather forecast, and delete weather forecast that, this is what any framework would be doing, but I'm not going to use an Entity framework for the demo. So we don't have to worry too much about that. Any questions so far? All right, so the first thing we want to do in our domain project now, this is where we're going to start doing some actual fun stuff. There's different ways to do this. This is just the way I'm doing it for the demo to make life simple. Again, there are plenty of debates on all of the Stack Overflows, Reddits, and Twitters of how to organize your commands and your handlers This is just the way I do it, and it's the simplest way for demo purposes. Again, more complex applications, you probably want to think a little more about how you organize the stuff. We have commands. We'll have handlers and queries. So this is how we're going to kind of organize our stuff. Any command, we'll put in the command. Any handlers will be in the handler. Any queries will go into the queries. So let's go back to our forecast controller. We want our get weather forecast. So now, as part of this, we can say private read only Mediator. Adding a reference to Mediator at the top here in our using. And I don't like to type code, so I let Visual Studio code it for me. Then this is just your standard DI setting up. We need an instance of the Mediator service, whatever you want to call it, which is just an iMediator. So now, if we do this right, we're going to say, it's like it knows what I want to type. This is crazy.
Yeah, that's a sweet feature.
All right.
It's a scary feature.
Yes. Yeah. If you haven't looked at some of the new stuff at Capable, and when you tap in, I actually got GitHub's Copilot running too, so it gets a little too smart for yours. We're going to be making a get weather forecast query is what we're going to be doing, because this is get only data, so it's a query, not a command. So my queries, I'm going to add a class, get weather forecast query, and it's perfectly fine to name them like this. And that's part of this. This is where I said I want to sprinkle in a little DDD. Name these things business. This isn't the best example, but name them business functions. So it's get weather forecast query. That's exactly what it is. Don't try to be cute about it and shorten it or whatever. That's when you start doing these in actual code, you'll start to get these like run-on sentences of command names. And it's fine, because that's perfect. That's, people talk about wanting to have code that is self-documenting. That's the best way. You look at something that says, process payroll for unpaid employees command. There's no doubt in your mind exactly what that thing's doing. It's not just some payroll service.process, and you're like, what exactly is that doing? That, oh, by the way, it takes a, enum in that tells it it's supposed to be for the payroll that hasn't been properly. Just make them straight and simple. There's no harm in writing big old long words in these. So you got to make it public, and then we're going to say this is an I. It's going to try to rewrite this whole thing for me because I've already done it once before. Cute. Shush. All right. So when I request with a return type of models dot, actually correct, I need an I enumerable. If I can spell it. Come on. And then it deletes everything. Does anyone else hate that it does that?
Oh, yeah.
That she'll be typing and it goes crazy like that. All right. So there we go. We want this. And this is it. Because we don't need to tell it anything. Now, probably in the real world, you'd say you want to pass in like number of days or something like that, so you get a 5-day forecast or whatever. By default, this is just going to be the standard, which is basically all. Anything that's in the database. This is get all. Yes?
So how do you decide when you're choosing what queries to create, whether you have a get weather forecast query with an argument or different weather forecast queries, like 5 days, 10 days?
Okay. So he's basically asking, how would you make the decision on if you would do a get weather forecast where you have a parameter in here of saying how many days, or make an actual query that says get weather or get 5-day weather forecast. it's really up to you. It's your call how you want to build the code out, whatever makes sense to you. If it's a very simple application that's very structured, so we only want 3-day, 5-day, and 7-day forecasts, you can make it separate if you wanted to. And there's no harm in doing it that way. But again, then you're going to have to build 3 separate handlers, which would then mean a lot of duplicate code possibly for something like that. So you probably would think in your mind, well, I'll probably just pass in a number of days, and then it's just one query, one handler, and then I can get whatever amount of days I want to come back to it. So that simplifies it. But if there's a need to maybe do some different logic internally because of a 3-day, maybe a 3-day only returns temperatures, a weather forecast that includes temperatures, whereas 5-day will also include, rain or something like that. So and that's another one of those things with CQRS pattern and domain-driven design points out there's no harm in having multiple models for what you're doing. This is a real simple one, so we're just going to use the weather forecast, but we could have a 3-day weather forecast object and a 5-day weather forecast object because we want different data to flow through the system. You can do that, and it's encouraged. Do it that way. Build the code to suit your needs. Don't try to always use the lowest common denominator if you do not have to. So again, that's one of those discussions that you'll set in some code room with a bunch of guys and girls and bash each other, yelling back and forth, no, this way, no, this way, no, this way. And someone will finally say, screw it, we're doing it this way. And then 5 months later, you end up ripping it out and changing it back the other way because that was the way you wanted it after all.
And then someone will say, but what about in 15 years when we want to do it this way?
Exactly. Someone will say that. They will say, well, what about if we need to change it in 15 years? And everyone goes, that's not my problem. I won't be working here.
Alan, can we take a look at weather forecast class?
Oh, we want to look at the weather forecast. So this is the default one that came with when you start up the new. The only difference I had was the ID because let's be honest, any real object you got an ID on. It's got to be a GUID or an int or something. But it basically has a date, a temperature in Celsius, and then a helper function to convert it to Fahrenheit, and then a summary string that'll say if it's clear, rainy, whatever. So yeah, that's that.
So where is your repository kind of class that you added? Which one is that?
That's up in the data access. That's sort of my repository simplified. So yeah, you can see here's your summaries, freezing, bracing, chilling. I don't know. It's whatever the Microsoft people put together for a demo,
So we haven't hooked this up with Mediator yet, right?
No, we're working on that right now. So here's our query. So this is the query that Mediator will process. Now we need to have a handler to actually process the request. So now we go add new class. We'll call it get.
So far we haven't identified the nature of the query, just the return type.
Yeah, at this point, because we're not passing anything in, this is about the simplest of queries to make. Is it says get weather forecast. So get weather forecast handler. And again, naming conventions sort of dictate that you probably should, for queries, put query in them. Keep them in a query folder, name them that ends in query. Handler should be put in a handler folder, and like I said, I will say this is where debates sometimes get, is that the handler should be next to the query or the command. So some people don't like having a proper handler folder. They would rather have this get weather forecast handler be in the queries folder. But that's when you get into that whole dogmatic, like, well, but it's a handler, it's not a query, and that folder is called queries, so why is it in there? And yes.
One thing, I use this library quite a bit. We have a features folder. Inside the feature, we have a high-level object. We call it, say, maybe like get weather forecast. Inside of that, we have a request object and a handler object.
Yep.
They live together.
Yeah, that's, as you were saying, a lot of times they actually, instead of focusing on having separate command, handler, query, you focus on the actual feature. So like get weather forecast, and then you put your handler and the query in there. And that's actually how in production, real world environments, how I've done it, because it tends to be, because I like it, my handler next to my query or my handler next to my command, just for ease of, you don't have to look in 2 whole separate places, because you start building a lot of these. Next thing you know, you have 100, you got 200 commands and queries. scrolling up and down to find the matching handle to it. It's kind of annoying. So that's, yeah, this is like the bare bones, truly dogmatic approach. But like I say, there's no right or wrong way. Do it however you want. This is just sort of the way to quickly show our demo. All right. Just make that public. So our get weather forecast handler is an I request handler that is going to handle our get weather forecast query. And again, like I say, I hate that we have to do this because this gets so annoying. Enumerable of models dot weather forecast. So let me see if I can shrink that down just a wee bit. But as you can see, it's just, again, it's defining the return type that's going to be returned by the handler. And again, because I don't like writing code, there we go. We're basically defining that we're going to be returning an enumerable of weather forecast, and it's handling with the request. Now we also need our data access layer. So private read only. That's my old, stop that. Demo data. It really wants to do some code that I don't have. Our demo data access, and again, we do need, just like any other system, you have to new up any of those private objects in your constructor. And this will all be handled by the DI framework and that add mediator at the beginning. So now we have a demo data access object. So, there we go. So, pretty simple. We're going to call our data access and say get weather forecasts, and we'll be returning it. Bada bing, bada boom. Yes?
I might have missed something in the overview, but why are we returning more than one forecast?
Well, that's the original was basically get forecasts. So it was returning, you know, all the forecasts that the system has for all intents and purposes. So yeah, I'm at this point just taking the current API that existed in that original project, reworking it in our new fancy pants way. That's it. Now, I know everyone's going to say, like, all right, this is like way more code and a whole lot of boilerplate than the old code that was just inline, hit the damn, you know, just why can't I just in my controller go to my entity framework and query my data? Again, that's like not a good way to do it. It doesn't scale. Code is complex. Again, this is a very simple version, but when you start building more complex systems, it starts to make more sense, and it starts to create a more logical understanding of, like, this is nice to break things down into individual little pieces that are focused just on handling one thing at a time, as opposed to building a big complex thing that's handling multiple things depending on parameters. And all right, so like I say, I need to step back. That should be domain. This is just an annoyance of it. You just have to reference an object in the domain project. So you can reference any one you want. It needs to know which basically app domain area namespace it's using. Yes, you could throw together tie these together and call off as many as you want. Which again, you might end up doing in a more complex system, because you might want to have a domain for the weather domain and then some other domain and a different domain, and a way of breaking those up into smaller chunks and pieces, that's part of the domain-driven design, is like breaking them in. Everything should be focused in an area. Like, this is all weather domain-related stuff, so I'm just calling it domain. I don't need to call it anything else. Who cares? But in the real world, I would encourage you not to use domain.
So the diagram with the mediator in the center, that would be the domain project is the mediator?
Well, that's where all the mediator's code is going. That's where all the messages and the handlers are going to be in that domain project. Because that's, again, we want to make sure that the web project has no business logic in it. When you look, like I say, let me say that here. If we go back to the controller, all right, now we can do the reference. All right, it's whining about something. What did I do wrong here? Hold on. But we don't want any business logic in here. We don't want to reference 10 different specialty services, because that's what often will happen is you'll have a whole lot of business logic in your controllers here. You'll have a whole bunch of, this one's real simple. It's got an iLogger and an iMediator, object being handed into it. But how many of the places have you worked at where that code is 5, 10, 15, 20 different object services of some sort getting passed in? Because every one of your functions or methods within needs this service, this service, and this service. And then the update needs this service, and this service, and this service. And then the delete needs that service and that service. Well,
So Alan, if you wanted to pass the parameters other than, the type, which is statically known by runtime parameters, those would be properties of the query object?
yes. Which we'll see here in just a minute. What is, what's going on here? Yeah. I think that's what's going on. Are we happy? Oh, yeah, dink. All right, see, this is what happens when you live code people.
The pressure of performing.
So many generics.
Yep, you start to do it. All right, let's see if it builds now. In theory, I've written all my code correctly. Hey, build succeeded. Woohoo! All right, and that's it. Mic drop. Pff, walk. You don't need to prove it. It works, I swear.
People without limitations.
All right, so in theory, if we execute, hey, look, we got our data back. Yes, it is raining right now outside, in case you don't know. Okay. So at that point, we've now got everything wired up. We've got our data access, which we're just kind of waving our hands here, but normally that'd be a little more complicated. We have our domain, which we're putting all our business logic in. We have our models, where we're storing our models. We have our web application, which has no business logic in it whatsoever. It is just calling a mediator, and the mediator is handling everything. Clean, simple. Which you'll start to love when you start having more complex objects that end up just having these one-liners. Or sometimes they won't be one-liners because, again, as brought up, if this get weather forecast query needed a number of days in it, well, then you got to, parse some query fields and build the object a little more complex. But for the most part, the only thing you're building is the request object, throw into the mediator, getting a result back. We're done. Again, sometimes you might have to add a little extra logic, but the goal is to try to hide as much of that inside each of these. And so your handlers is now the abstraction of where this goes. So what's another one we know we're going to probably need? So we're going to need a public async. In this case, just going to be a task delete int ID. This is an easy one, a delete function. Sometimes it'll write it correctly for you, other times it just doesn't want to do it. So we're going to be sending a delete, HTTP delete with an ID. and we'll run some code internally. So I'll turn 08. Again, this thing knows too much. What's it whining about now? Oh, it's right, isn't it? It's lowercase. So we're going to make, although this is wrong, it shouldn't be a delete weather forecast query. It should be a command, because that's what we're doing. We're I know, it thought it was being cute and just going to throw that query on the end, and you're like, nope, you're wrong. Now this time we're going to do an request. Oops, come on. But we're not going to do a return type because we don't care. Which is, so you mentioned, well, how do you do if you don't? So we will say public, and then we need to have our int of ID so that we know what we're deleting. So let's see, we got our delete. Actually, I can just paste it in there. Hey. Our delete weather forecast handler. Oop. This is my request handler of delete weather forecast command. So we should be able to
Since we're here, you know the hooking of program handler, everything how the assembly with it. Is it done by kind of static code generation, or is it done through reflection?
it's reflection. Yeah. If
Is there any overhead concern?
it's all, on boot up, it scans that all and then it stores it somehow behind the scenes and sets it all up for Mediator. It's the way it is. So I've never looked at if I would assume they've optimized it correctly so that it provides the most performance, that they choose to do it that way over any other way.
So slightly slower startup, by the way.
Yeah, you get a little slightly slower startup because that goes back to the program here when it calls that add mediator. It's going to scan through and find everything of an iRequest and everything of an iRequest handler and get that all wired up so that it can connect those. So it's probably just doing some kind of internal list or dictionary. It's probably just a dictionary. I bet. The code's public, open source, so feel free to look at the Mediator code. I'm guessing it's pretty simple dictionary. It loads all that up, and then when anything comes in of a, delete weather forecast command, it figures out which handler and then just runs that handler for it.
Was the handler a static method?
No.
Because then there is an activator code somewhere, right? And then overhead.
Well, that's, yeah, because you have to, again, because of, I think, the DI framework and how it all works, that's the way it wants to do it. So yeah, there's going to be some overhead, but I guess if you were so worried about performance at that level, then you might want to roll your own Mediator pattern so you could do it your way. And again, you could do it. No one says you got to use it. This is a very simple library that spares me from writing all that boilerplate code that I don't want to deal with. That's, as everything. I want to focus on the business needs, not doing a whole bunch of plumbing. All right. So at this point, we need to do the same thing as we always do. Public, private, my fault. Habit. It really doesn't like that. See, this is some of my old demo code that I threw away, and it keeps wanting to use it for whatever reason. Demo data, access. What do we call it in the other one? I forget now. Did I call it? Yeah, I did call it demo data access. All right. Let's make sure I keep it the same way for. Oops, dang it. I don't want to get yelled at by my code reviewer for using different variable names. Again, it has to be newed up and created as part of that. So at this point, we call our, look at that. It knows what I wanted. It's almost like you don't have to code anymore. I mean, come on. Like, it just does it for you. But again, we have some fake stuff, so it's just we're saying delete the weather forecast, and we pass in an ID. And we do have to return a unit task. There's a little bit of plumbing involved when you do things this way.
Could you show the calling of it, this message send? So this is what's being called.
Oh yeah, I can step through it. Is that what you want?
Yeah, because I'm wondering. So the idea with the handler is that you have smaller injection containers.
Yep.
Instead of a large monolith. That's the idea about efficiency.
Yeah, that's, as he was asking, that's what our goal is, that we want to build small pieces of code that just deal with what we need. And this is sort of how you do that.
How does the routing work then on the message send?
So you want to know how the routing works? What do you mean by how
Well, you have the handler. So can you show what calls it?
well, that's what the mediator itself does. If you look at the controller, that's where mediator send, you say query. Mediator, it's the engine that goes get weather forecast query means I need to run the get weather forecast handler.
So it looks like what's happening is that this is the routing from my request delete command, right? It goes reflection, finds that delete command, sees who is implementing the I handler for the same type, and then calls the appropriate handle command of that type. So the thing
So
that
it's the I
glues them
request.
together is
It's the I request typing that defines the routing.
so what glues them together is that command type, and that command type on one hand is I request interfacing that is implemented by same side, and then
All
the
right,
handler
I'm gonna
on
cheat.
the receiving side. So mediator glues the two processes that implement one and the other.
I see.
See, I mean, so I
Okay.
request handler item, this is the handler, so all the handle methods of this type.
All right, hold on. What did I do? Sorry, it's whining. I want to check and see what code I did wrong. What did I'm going to cheat. All right, at this point, we're going to switch over to my other code because I'm starting to run low on time here. I don't want to rewrite all of them. So what I ended up doing was making our get that we already did, the delete, which we just worked on, and then I did an insert that takes a weather forecast object, so you can pass in your day temperature summary and it'll create a new one. So again, the idea is you have a command, this is going to take, it's going to have some actual parameters to pass in, and it returns the new weather forecast object. So again, like this is 3 API endpoints in 30 lines of code. That's pretty nice compared to most. Yes?
So, this may be a simple question. On line 35, you got a task or type unit. Is unit a mediator thing, or where's that coming from?
That's part of the whole async based. It's so because of the way, if you want to return items and stuff, that it's mediator's unit, because I don't know, it's part of how it handles returning nothing. I'm not very good at explaining it, but
That tooltip's pretty good, actually.
Yeah, I mean, it's, I guess it does, yeah, it represents a void type since void is not a valid return type. Because, yeah, you can't return void. You have to return something. So otherwise, you'd have to, like, return bools or something. So they sort of made this generic unit so that your asyncs can return things.
I think on your iRequest handler, it's just the one type. You could change that task unit to just void and it still works.
Yeah, I think you might be able to.
Let's go to the just task, right?
Yeah, just task here, but then at the handler itself, on the handle method, just make it a type task without task unit, and it becomes a void. And that used to work.
It used to work, yes.
It doesn't in the new version.
I don't know if it works for Meteor now, but yeah.
Looks like it doesn't like that.
Yeah, and that's part of the interface.
Yeah.
Well, we get return, so maybe you could,
That's,
return unit task.
I think,
That's the interface was not happy.
yeah, that's, yeah, they have done a bunch of functional changes. That's our the project I'm on right now. We're still using version 8 just because they did change a bunch of the stuff and we didn't want to have to like refactor all our code. So, you know, we got a backlog item, refactor code for updated Mediator, and we're like, we'll get to that someday. So where were we at? All right, so let's undo that. There we go. So at this point, let's fire it off. Flash. So hey, now we got new functions. So we call get. We execute. We're getting 5 items back. You know what? I don't want to delete number 1 because I'm that way. I hate that weather forecast. And it ran. Of course, there's nothing to respond to it because it returns nothing. But if we run this again, oh my goodness, the first one's gone. And then as well, here's a post for creating. ID doesn't matter because it ignores that, but we'll do a date, temperature. It's boiling. That's 100 Celsius. If you don't know, that is boiling. Yes.
Yeah.
This is just the weather. And we'll say hot, hot, hot. And we execute, and it returns, and we see we get ID 6. So then again, if we go back up to here, we re-execute. Here's our new one, hot, hot, hot. Yes?
All right, I've been holding this question back the whole time.
Okay.
So that post command, is that a command or a query?
That is,
Yeah, that's a good one.
that's a command.
Okay.
Yes.
I just wonder if your post, does it return the object that was created or doesn't?
Yes. And that's where you start to get into these funny ideas of like what you should or shouldn't. You know, unfortunately, in most systems, you want to return the object because you probably need it immediately. Okay. So yeah, I mean, and that's, I consider that acceptable. Like commands change, the point is a command changes data, it can still return data. I mean, commands don't always have to not return anything. It's fine for them to return, but the focus on command versus query is that your query should never change anything. If I call get weather and then I call get weather again, it shouldn't change because it, you know, get weather should not be adding weather to the system or deleting weather. So that would be one of those cases where like I know some people make code that is like get next available and it'll delete the item and return it, you know, as all some kind of being smart. That sort of breaks that concept of you should have a command, you know, that says delete. So you say get next, and then you need to fire off a command that says delete it. You know, keeping things separate. So at that point, here we go. We have a functional app. Almost, you know, we're probably short a few hundred API calls to actually, you know, take on weather.com. But you know, we're getting there. You know, mostly we need to actually get real weather data somewhere. So that might be where you create what you would call a weather service that might hook into, you know, some weather thermometer remote systems to measure your, you know, temperatures or something like that. And then you would make reference to that weather service in each one of those handlers because you might need them to pull data or something like that. But at the end of the day, that's, so I guess I can, like I said, I can step through so you can kind of see the flow. So let's put some breakpoints actually on the get weather. So we're going to slap a breakpoint on both the constructor and the handler. And let's go to the controller and go ahead and slap one there because we like breakpoints everywhere. So here's our get. We're going to try it out. Hit execute. All right, we're dropped in here. So you can see at this point, we haven't actually created an instance of the handler, anything like that. So we'll call this. At this point, look, we called the send function. It's creating the handler right now. So we're in the constructor. And it created a demo data access as part of the DI framework to pass it in. So we had that. We create it. And then immediately, once it's been created, Mediator now calls the handler. And we ran our code. And we returned it and got our results. So that's the flow of it. It is in time creating the handler and using it. And it'll do that every time just because of unknowns. I think there might be some optimizations where you can say, like, once you create it, keep it. But by default, it's going to create them each time so you know you got a new, fresh, happy handler to handle your request. And that's it.
The injection container registration is Mediator just knows about that and then does its own injection on top of what the DI is doing?
I believe internally, yeah, that it's creating it. I think it's tapping into the DI framework somehow. Like I said, I've never delved into how Mediator itself works. It's, as far as I'm concerned, it's a magical black box that I throw a command at it or a query at it, and it returns a handler for me. I haven't bothered like digging deep into the code.
What's the startup? That was the first view of the program?
That was the right here. Just had to say add Mediator and pass in the assembly, which we want the domain project assembly. And it will use reflection to scan through and find every iRequest, every iRequest handler, and that's the whole purpose of the Mediator. Is Mediator is taking care of all the work for you. You don't have to write any code to create the handlers, process the. You just create a handler, create a message. Mediator takes care of the rest for you. So it's almost like a DI framework in a way. Yeah. I mean, you can think of it as sort of a little step above the DI framework because you're sort of in real time demanding it do things for you. So, it jumped ahead on me. I hate when it does that. Don't blink, I'll give you a seizure. All right, so at this point, I think we've had plenty of questions and comments.
I got one for you.
All right, we got one more.
So, when I think about CQRS, I think a lot about the potential for separating your data into two different databases, right?
Yep.
A read and a write one. How does that mesh with Mediator? Like, does Mediator play into that at all?
Okay, so the question is, when we're talking about CQRS, as I mentioned in some of the things about performance, the idea of having two different databases, one for reading, one for writing, and how Mediator kind of plays into that. That's where this all kind of, it's the magic sauce. When you put these all together, they work so well to do that kind of thing, because your command might reference entity framework, and it creates an instance of DB context that's your write database. And you use that and the handlers for, insert customer or whatever. But the get all customers that have paid a bill in the last month query, maybe it goes to a MongoDB instance. And so you reference your MongoDB instance system or some other document DB, or maybe it goes to Entity Framework, but there's a different DB context that is going to a read-only mirrored copy of the database. And so that's only the bits of the code that you need, only those helper classes, those helper services are what you're going to add in that handler to do that. And so that's where it feels really brilliant because it makes it very clear. You can look at a handler and be like, what do you know? Private read-only MongoDB client. Okay, apparently we're not talking to the SQL database with this one. Okay, I know exactly what's happening now. There's no question, there's no Entity Framework reference. I can't do anything with Entity Framework in this one. And so it helps you. That's one of those things where it just helps. It's small code with only the bits you need right there to process it. And at the end of the day, you still have all the logic, all the domain functionality, all the business logic is all there. It's just, this is a different way of doing it. Instead of building that one big, ugly God service that has 30,000 lines of code, you might have 20 or 30 or even 100 commands and queries that each do each piece individually. Now that's where people start going, well, yeah, but there's a lot of duplicate code. That's where you might make helper classes, where you might end up making a billing service where some of that shared code could go to so that you aren't copy and pasting it 10 times in 10 different commands because you need that same bit of code. And that's fine, but it's about changing your thought pattern, changing the practice of how you organize your code into a more streamlined approach. And this is why I wanted to talk about this and share it, just because it starts to make life so much easier, because one of the great things is you can pretty well know, assuming people name their commands and their queries very well, and they don't make them all generic and horribly named. If someone says something like, well, we need to go get all the customers that haven't been billed this month. All right, well, I'll go to my queries folder, maybe, and I'll start reading through every object name in there, or every class. Customer, 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 customer. Oh, customer not billed. I think someone's already done that work for me for this report I need to do. I can just call that mediator, get that data. This time I'll shape it into a Excel spreadsheet and send it back. Yay, I just spared myself a lot of time digging through code or having to harass people. Guys, anyone know if we already got something that'll give me? You can easily do that, So I find it very useful, and it's been sort of refreshing in how well the code works. Plus, there's a whole lot less, merge conflicts, because most of the time you're all working in different sections. You don't ever have to worry about ugly merge conflicts because everyone's in the, billing service, and everyone's refactoring and shifting around, because there's always that one guy that wants to alphabetize everything, and then he does the commit, and it literally is every line code changed, and you hate dealing with that. All right, any other questions? Anything on the YouTubes?
No questions on the YouTube.
All right.
We have one over there.
Oh, we got another one?
Yeah, sorry. Wanted to make a comment. It's an interesting pattern. There was a developer I worked with who was phenomenal, and we kind of wrote in the same style of Mediator. And within, I'd review code, or 24 hours, we get a request. So he'd move from Azure Service Bus as the connecting technology to MSMQ as a connecting technology, and then over to a web app with REST endpoints. And as long as you keep those surfaces, those bindings clean, the only responsibility is checking the inputs and then dispatching
Yep.
the request for work, right?
That's where the
He
yeah.
was phenomenally fast.
That's one of those bullet points I said. Simplicity is when you need to make big changes, like change the data access layer that you're going to go to, or all right, screw it, we're not using Azure anymore, we're using AWS, which means you got to rip out a whole bunch of Azure specific code, it's a lot easier when it's these little independent entities that you're working on, because it doesn't get it limits the complexity. Yes?
I don't know, do we have time?
Oh, there's always time. I mean, how about we take it offline? We can take things off at this point. So thank you, everyone, for listening and putting up with my live coding, and hopefully I didn't bore you too much, and I explained things well. Basically, resource-wise, I think that the two best places to hit is obviously the Mediator GitHub. So you can go to github.com/jbogard Mediator. And then there's a Microsoft, this is Microsoft specific, but they cover a whole lot of patterns in the Microsoft documentation on architectures and patterns. And so there's a CQRS pattern. This goes into a lot more detail, and it's a lot focused on, as we brought up, the idea of, you know, commands go to one database, queries go to another database. How does that work? You know, the benefits of that, and it explains some of those things in a little more details, and kind of the pros and cons of building systems that way. Because there are obviously cons to doing things that way. You get into issues of consistency of someone updates, well, how long does it take before it actually shows up for a query to get the results back, and how do you deal with those situations and things like that. And then domain-driven design, these are like the three major books. At this point, there's like 15 different domain-driven design books, but if you're in the .NET C# world, these are your three that you want to hit. So I can't read them on mine, but it's, you know, implementing domain-driven design, the domain-driven design, which is, Eric Evans is basically sort of like the god of domain-driven design. So this is his book. That's the one you want to read, definitely. But the implementing domain-driven design, this one's more of a conceptual explanation. The implementing really is focused on the nitty-gritty of how to actually build your code, organize your code. So when everyone gets in that fight of, well, where do we put it? Well, how should we organize it? That's the one that'll answer most of that. And then as well as the patterns, principles, and practices of domain-driven design with Scott Miller and Nick. They're sort of that one will kind of focus on C# specifically. That is the one thing, the domain-driven design implementation, I believe it actually does Java, not C#. But it's close enough that you can understand the patterns. So if you want to do more C#, the patterns and practices, that's the one you want to do. So with that, thank you very much for listening to my ramblings, and I'm looking forward to seeing you all next month.